Hi everyone. Let us discuss the topic on sensor. What is a sensor? A sensor is a device that responds to a physical stimuli such as heat, light, sound, pressure, and converts that into signal, which can be read by an observer or an instrument. There are different types of sensors: chemical sensor, electrochemical sensor, and optical sensor. What is an electrochemical sensor? These sensors use electrode as transducer component. The main components of electrochemical sensors are working or sensing electrode, electrolyte, counter, and reference electrode. Let us take one example of this electrochemical sensor and discuss on the construction and working. So we are going to discuss on the construction and working of pH sensor, which is used to determine the pH of the solution. For that, we take the example of glass electrode. So now we are going to discuss on the construction and working of a glass electrode. These electrodes, particularly these electrodes, glass electrodes, have the ability to respond to specific ions and develop a potential in the mixture and ignoring the other ion. So when we are talking on this glass electrode, which is particularly responsible for the H plus ion, okay, it will respond for the H plus ion so that we could determine the pH of the solution. So this is a diagram given for the glass electrode. Let us discuss on the components, what and all it consists of. It consists of, this glass electrode consists of a long glass tube with a thin glass membrane bulb at the bottom, which is made up of a special type of Corning glass. What is that chemical formula of that? Sodium silicate, Na2SiO3. The Corning glass has low melting point and high electrical conductivity. The bulb is filled with, inside the bulb, it is filled with 0.1 m HCl and is inserted with the AgCl electrode in it. It is also used for the external contact. And 1 m HCl is taken in a beaker and the electrode is immersed inside it. The cell is represented as, here you can see the cell representation written here, Ag/AgCl/0.1 m HCl and /glass. This is the representation of the glass electrode. And here above this, you can find another way of representing the glass electrode. There is solution to be analyzed. Here the concentration of metal ion, that is nothing plus H plus ion concentration is kept C1. Membrane, what is this membrane? Membrane is nothing but the glass bulb. Then internal standard solution, the solution, analyte solution. There the concentration of Mn plus is C2 and the internal reference electrode. Internal standard solution is actually 0.1 m HCl solution. Analyte solution is taken in a beaker. So this is another way of representing the glass electrode. So now let us discuss on the derivation of the potential equation of glass electrode. So when we take the glass electrode potential value calculation, we have to calculate the boundary electrode potential and reference electrode potential. In order to make it clear, let us take the diagram once again. Here, near the glass bulb, you can find two boundaries are found. One is denoted as E1, another one is denoted as E2. The difference between this only we are going to calculate. That is noted as an EB, boundary potential. And if you look into the glass electrode diagram, we have the reference electrode inside. That is silver chloride electrode. The potential related to this reference electrode we name as an E reference. That is a reference electrode potential. So when you're calculating the glass electrode potential, it includes the boundary electrode potential as well as the reference electrode potential. So to know the equation, potential equation for this, we have to start the equation, that is which has the concentration C1 and C2. Actually, you can relate this equation with the concentration cell under electrochemistry so that it will be easy for you. What is the C1 here? C1 is the concentration of analyte solution, H plus ions, where the HCl is taken, and C2 the concentration of the internal standard solution, that is 0.1 m HCl. Okay. So EB, again you can rewrite the equation above equation as EB equal to 0.0591 divided by N. log C1 minus 0.0591 divided by n log C2. So now the second part of this 0.0591 minus the entire term C2 term is kept constant, that is denoted by K. So substitute this K in the above boundary potential equation. So you will get EB equal to 0.0591 divided by n log C1 plus K. So now we are going to introduce this value for the bound EG value calculation. So what is the EB? Already we found this above formula. Substitute that and plus the E references added up here. So let us move for the next step. Here already we have the two constant terms, what and all, K and E reference electrode potential. E reference electrode value will be constant, silver chloride. So that also can be added up. So with the K value. So together we give the one constant term as an E naught G. So now substitute this in the place of K plus E reference, E naught G. So we will get EG equal to E naught G plus 0.0591 divided by n log C1. What is the C1? C1 is nothing but a analyte solution. So what is there in the analyte solution? HCl. So in the place of C1, we are going to substitute the H plus ions. So now what we have? Log H plus. Can we relate that with the pH equation? What is the pH equation? pH equal to minus log H plus. So in the place of log H plus, we are substituting minus pH. Then what is the value of N for hydrogen ions? The value of N for hydrogen ion is 1. So substitute this value and get the final equation. So you will get the final equation as an Eg equal to E naught G minus 0.0591 pH. This is a final Eg formula. So by using this, we are going to determine the pH of the solution. So what are the electrodes required for the pH determination? There are two electrodes required for the pH determination. One is calomel electrode, it is a reference electrode. Another one is a glass electrode, that is an indicator electrode. Let us look into the representation of this cell. Suppose you are asked to determine the pH. How to write the equation? So at the left hand side, we are taking calomel electrode. It is represented as mercury Hg slash Hg to Cl slash Cl minus. And solution to be analyzed is taken as an unknown pH solution in a beaker. Then you have to write the glass electrode, that is that representation in a reverse way. From glass, you have to start right. Okay. So at the left hand side, calomel electrode, and right hand side, we take as an glass electrode. So what will be the E cell formula then? E cell equal to E cathode minus anode. So what is cathode here? Glass electrode. So in the place of cathode, we have represented as capital G. That is nothing but glass electrode. At the anode side, what is there? At the anode side, we have calomel electrode. In most of the time, we use the saturated calomel electrode. So the potential of this saturated calomel electrode is 0.24 volt. So this is a value given. You no need to substitute, just you can write as an E calomel. So E cell equal to E naught G minus 0.0591 pH. This is a value for the EG. Then minus E calomel electrode as it is given. Okay, no need to give the value here. Later we'll substitute. So pH, you bring back this 0.0591 pH here, other side. So you'll get E naught G minus E calomel. This E cell can be shifted in the other side, minus E cell. So when you bring that 0.0591 down, you will get the pH alone. So this is a final formula for the pH. pH equal to E naught G minus E calomel minus E cell divided by 0.0591. So up to this, you have to derive the equation. So that is named as a pH formula. So now let us look into the advantages of glass electrode. What are the advantages? The first one is it can be used in the presence of oxidizing and reducing agents. And second is electrode does not get poisoned. And third one is it is simple to operate and is used in industries and agricultural labs. But another important note, the pH range of these electrodes can be measured up to 1 to 9. By using the special glass, we can determine the pH up to 14 also. Let us look into the disadvantages of this. Because of high resistance of glass, simple potentiometers cannot be used. It needs a highly sensitive electronic potentiometer. So suppose the pH, another important note, up to pH 9, we can, pH 13 we can, but after 9 pH, there is it is sensitive towards the Na plus ions. This leads to alkaline error. These are the two disadvantages of using this pH electrode, that is a glass electrode. Let us look into the applications. Where do we use this? It is used to find the concentrations of electrolyte solution at anodes and cathodes. And second is, it is used to measure the level of carbon dioxide in blood sample. So this video we have discussed on the pH sensor, that is glass electrode construction and working. So let us look into this once, understand. Thank you.